Going live, yeah, went live. Hi YouTube. If you don't know, I mainly focus on streaming to Twitch, but everything is also restreamed to YouTube at the same time, so you can watch there if you prefer. And later you can watch everything, all the archive. High qualified. We'll start with erasing vertices from this Grand Contest 49. Hi Nihal, how are you? Let's go. We have a directed graph with n vertices, and strings of lengths represent edges. Oh, they mean just binary matrix of edges. Repeat the following operation. Choose an erased vertex uniformly at random. Erase this vertex and all vertices to which you can get. Find the expected value of the number of times the operation is done. I'm quite sure we need to count vertices to which there are no edges. I'm good at probabilities and expected value, so this one will be easy. I prefer if a hard problem in a contest is about expected value, because the first problem I'm able to solve anyway. And then it's harder for other problems. So if there is a graph, does it matter at all what are those edges? And the game will end if this vertex is removed and this vertex is removed. It doesn't matter if earlier I erased those. But we have the following three scenarios. Choose vertex 1 in the first operation, erasing that, alright. Choose vertex 2. Okay. The thing is, if I erase this in the first operation, then for sure I will keep erasing those. If I erase this instead, I have 4 to go. So the game ends when those vertices are removed. It's just that for every other vertex it would be nice to compute probability that it is removed with an operation. If we look at this guy, what's the probability that you are ever removed, that I have a move that removes this one, this vertex? Well, it must go before them. Oh, even 1, it removes everything, right? Then erase that vertex and all vertices that are reachable from the chosen vertex. But again, this gets... I will do an operation if none of those happened before. I don't care about those. What about this? This will give me an operation with this probability, 1/4. Because out of those 4 vertices, I want u to be the first one. Similarly, this one, I will waste an operation on u with this probability. U will give me one operation for sure, and so on. For every vertex in this graph, I care about size of the graph from which you can get here, including u, and out of all those vertices, there is probability 1 over s, where s is the number of them, such that this vertex is first erased one. So we have an operation. That will be my solution. For every vertex, compute the number of vertices from which you can reach this vertex, and add to the answer 1 over s. I need to turn on the virtual machine with Linux. Oh, I need to set up the today command. Solving very hard competitive programming problems from Atcoder Grant Contest 49. All right. Oh, qualified if you try again. Now it should work. The problem was read number of vertices in a graph, then read that two-dimensional array. Now S of ij will be 1 if there's an edge. What do I need to do for every vertex? For every vertex, let's call the vertex A. Count vertices from which you can reach A. That's the task we need to do. And for that, I can traverse graph backwards from A. Let's say I will call them group V. This is like anti-reachable, but let's call it reachable. Insert A. It's a bit like DFS. I'm basically running BFS on reversed graph. Now, for every new vertex, if there is an edge from y to x, so from x to y in the reversed graph, reversed isn't really the best word, then reachable pushback y. And also I don't want multiple instances of the same thing, so visit it. And now this is BFS. Answer plus equal, as I told you, it's 1 over the size. Reachable. Like that. All right. This should give us 166. Indeed. Let's print with bigger accuracy, and I can submit. Is this C++ 14? let's all think hard. ABC are the main problems for us. Indeed, this already problem available only for div1 participants, right? Okay, accepted, move on. Flip digits is the second problem. Any tips for Couchflong challenges? Practice. There are no hidden tricks. There are two strings of length n, binary strings because they consist of zeros and ones. And regarding CodeChef, it also makes sense to print problem statements or just read them and then think while you do other things. Like, I don't know, while doing homework from boring subjects, I used to think about solutions to Couchflong problems. Okay, from the first string we want to get the second one, and the operation is that we change some bit from 1 to 0, but as an extra we flip the previous bit. If we look at this one, we want to get from 001, 110. We want to say if this is possible and how many operations we need. If we decide to flip this 1 to 0, then also the previous bit gets flipped. Then we have this and so on. The length is 500,000. My first idea is, what about doing this greedily from right to left? Let's investigate on this example. Because when I flip a bit, then also the previous one gets flipped, and I can only change from 1 to 0. Then it makes sense to go from right to left, right? Because if I fix this, forever it will be fixed. Okay, the goal is this. Oh, I don't see it, but the second string, 0, 1, that's the goal. Or target. And I looked at the last bit, it's bad, so I change it to 0. And also the previous one gets flipped. Then I look at this bit and I'm done. I cannot do anything. From 0 I cannot change to 1. Making this as the first operation is bad. I messed up. Then it's nice that they provided a sample test failing this greedy idea. Okay, then how to do it? Should I flip this first? Let's investigate. This. If then I touch you, then I lost. Maybe let's try this guy. 1 1 0 1 1. What now? This one? I will want you, that's good. I need to change you into 0 and you into 0. I see. Doing this now would mess things up. So I don't want to flip this and previous bit, because then I would get 1 0 0 1 0, but I want 1 here and I'm not able to do it now. No, instead a good operation is to first do this. We'll get 0 0 1 1 0. Then, well, this is bad. And we have 0 1 0 1 0. and that's the final string, that's the target one. We can get from 1 0 1 1 1 from this one in 1 2 3 4 5 operations, the final string. We don't need to print operations, it's enough to just say the number of steps. How to remember concepts in difficult topics? You don't remember them, you understand them. Just like, I don't know, knowing math. There's nothing much to remember, you need to understand it. I have solved about 600 LeetCode questions in practice, but still CodeChef ones are hard. They are completely different. Solving more LeetCode problems will not help you in CodeChef. At least not by a lot. If you want to learn competitive programming, including CodeChef, then you can, for example, check out Competitive Programmer's Handbook. Now, this free PDF. This will introduce you to the world of competitive programming. I pasted link in the chat. Are you writing on your computer? You can read about my hardware here, but no, I have a drawing tablet. Back to this. Let's think what happens on the far right. Depending on the last 2 bits, maybe. If the last bit is 1, if the last bit is 0, but it should be 1 at the end, then I lost, because I have no way to do this. Let's write this down. If it's like that and 0 at the end, like that and 1 at the end, then there is no answer. That's impossible. Then, if the last bit is the same, like this, or like this, sorry, I mean this. So if it's 0 and should be 0 at the end, by this I mean starting string and the target string. Starting string, target string. Here I do nothing, so just move on by 1 to the left, ignore this. Same if this is 1 1. And we also move to the left by 1. And finally, what happens if at the end we have 1 in the starting string and then in the target string there's this? Well, I need to eventually flip that. And this also flips the second last bit. This can be an issue if I have right now 1 here and I want to have 0 at the end, because by flipping both I mess things up. So in this single case I need to do first this flip, so it will be 1 0 and here whatever bit was reversed and so on, and from this I want to get the final string of 0 0 and whatever there was. Then, only then I want to do this one. Let's investigate what will happen. And now it will be the x. This means that if there was bit x previously on the third last position, now it's the reverse of that, the flipped state. Alright, this is that. And the target string, well, remains. It isn't changed. And now, because I want 0 here, now I could try to do this, but it might hurt in the same way. I want to try the thing with just going to the right and flipping the last bit if needed, unless this is the case. But I suspect that the problem is more complicated. So far I needed to make this step, right? Well, not necessarily now. Maybe I want to first do something on the left. Can there be some bit here that isn't good for me? Yeah, if this is 0, if x prime is 0, no, if this is 1, imagine that, what if x is 0, so then x prime is 1. Then I cannot now make this operation, but it seems that I just forget about 2 last bits. What's the problem? The problem is we are given 2 strings, 2 binary strings. I need to create, I need to start from the first one, create the latter one, by repeatedly making an operation of choosing some bit and flipping its state from 1 to 0. It must be 1 and then changes to 0, but also this flips the state of the previous bit. When I choose bit I minus 1 flips as well. The question is, what's the minimum number of operations needed to get from string S to string T? So far I would say that the answer is O of n, and I wonder if that's true. Answer is, how to write it, it's O of n. It doesn't go to n squared. But yeah, I'm not sure about this. It would be a bit easy. This was a 3-hour contest, not even that, 3 hours 20 minutes, so problems were quite difficult. My solution is look at last bit. If it's like that, say impossible. If it's like this, skip this bit, same here. If it's 1, 0, then flip the last bit, unless the situation is like that, from 1, 1 you want to get 0, 0. Then go with this one first. And only later you will do this. And after you do this, you don't want to get situation where from 1 you want to get 0. No. This is bad situation, from 0 to get 1. But this is 0, so it should be fine. Why doesn't greedy work? I'm thinking why greedy doesn't work. I want to greedily go from the right. And that's it. Well, it won't take me a lot of time to implement that. And if because here I don't see how this would fail. Let's spend 1 more minute. Okay? Let's spend 1 more minute trying to find a counter test. There is no counter test here because I only fail when I get to this situation. 0 needs to change into 1. That's not allowed. Also, if it's the very last position of the string, because I cannot change that. Yeah, that's actually, I didn't think about it. What if everything is 1, 1, 0, 0? Then I need to take this, because this one is not allowed. I mean, greedy should work since there is only one way to change the last unmatched bit. Yeah, but the question is, should we do it before or after we change the previous last bit? If here in 1100 you take this bit and you flip it along with the previous one, you lose. Wait, no, what am I talking about? Then you would win. This is bad, right? Yeah, okay. I did stuff incorrect. From 1, 1, if I want to get 1, 0, I cannot take this, because this would change both to 0, 0, I lose. Instead, I need to go with that one first. This, if the third last bit was x, now I will get x prime 0 and 1 and whatever on the left. Then only then let's say I want to touch this, then it's x prime 1 0, and yeah, the two last bits, they match. That means this goes before u. Similarly, we might need to say that this goes before u. Right? In this situation, what needs to happen is that we first solve this string, this prefix, and only then at the end, this prefix assuming that this, well, needs to change to 0. And only then we will do u. So I leave this as the last bit to do. And otherwise, this is like from 1 I need to get 0 here, and those two are zeros, or it's 0, 1, or 1, 0. Will it always work that I do u? What if this is the case? 1, 1, 0, 0, 0, 1. Right now, if I do this, I lose because of that. Instead, if I do this, I will get 1, 0. Then I do this, I get 1, 1, 0. Then I do this again to change it, and yeah, it doesn't make sense. Try every possible solution with backtracking. N is up to 500,000, so nothing exponential can work. It makes sense to investigate the correct solution using backtracking, but it also takes time. You can say that the order of operations doesn't matter. It does. It does matter, because you can change from 1 to 0, but not from 0 to 1. If you start from end, x0 is x1, 1. I didn't talk about case x0, 0. I talked about case with x1, 1. Okay. If I start from 1, 1, if I have 1, 1 at the end, and I want to have 1, 0, if I do this operation first, I lose. How about going from left to right? But if I go from left to right, in the future we get something, and it kind of tells us to change the previous operation, and that might tell us to change the previous operation. So that's bad. Before I implement, I need to look at standings to see if many people got wrong answers here. And nope, people solved it in 4 minutes. Not that many wrong answers. So let's assume that my solution so far is enough. I didn't think about details at the end. I will just, as I implement, think what needs to be done. The input is this, n, and one string and the other string. I don't want to deal with strings. It's hard to flip a bit. I need some ifs and characters. Let's say that there is a function to create a vector of Boolean values. Don't even need to pass that. Alright, now with vector of Boolean values it's easier to flip because it just, you know, like that, while for a string it would be much more difficult. Alright, this is, let's say, A. Did you understand why order matters? I can repeat that. If this is the situation, from 1, 1 you want to get 1, 0, you cannot touch this first because you will get 0, 0. That's it. If from something and 1, 1 you want to get at the end something and 0, 0, if you do this first, you will get 0, 0. No, what was I saying? Oh yeah, 1, 0. If I want to get at the end 1, 0. If this is your first operation that you messed up, you cannot now from 0 get 1. Okay, only up to 1. You cannot change the very first bit. If the very first bit, observation, no operation changes the parity of the whole string, so, you know, the parity of the number of ones, something like that. So if the last bit is messed up, if at the end A0 is not B0, then there is no solution, because apparently parity doesn't match. This is what happens after we fix all the other bits. Now, if A of I is 1, no, if this is 0, well, this is false, and B of I is true, this is impossible. Then, if they are equal, we hit continue. Right? I talked about that case, if maybe it's good to, for a moment, kick it. No. Then continue to the next I. And finally, a case where this is 1 and this is 0. From 1, change to 0. And I can do it. It would be like that. This would be the operation, but it won't work in some cases. And I wanted something special for the case of, what was the case? From 1, 1 get 1, 0. If this and that and this and not B of I. This is from 1, 1, 1, 0. What do I need to do in this case? I need to say that the rest of the string is done first, and only then I am. But this means that at the end I will use an operation here, and it will change the I minus 1. So I will change the requirement for you. This is because at the end I use operation on position I. This will also affect I minus 1. So if at the end I want to have true, then let's say that in the remaining part of this process I want to get false here, and then this operation will hit it back. In both cases, operations plus plus. You can shift zeros. Indeed, the zeros and ones aren't symmetrical. You can only hit it from 1 to 0, and then it always flips the neighbor, the left neighbor, and there are no requirements about that one. Let's try this one with 5. Minus 1, that's bad. Print to, that was in 3. Do I read correctly? Yeah, true, false, true, true, true. It's true. All right. After every I, or just before every I, I have some bool alpha thing here. Yeah, in C++, bool alpha will make true and false printed as true and false. Instead, I want 1 and 0. So I removed it from my template. From 1, 1, I want to get 1, 0. That's the special case. Is it? Yes, it is. It says that first I want to fix u into that. But no, it wasn't hit. From 1, 1. Oh yeah, from 1, 1 to 1, 0. This is a typo. This should be not. Now it's from 1, 1 to 1, 0. Also, yeah, this thing I forgot. Damn it. I'm looking at this bit and I want to say from 1, 0, 1, 1, I want to get 0, 1, 0, 0. And it seems that I cannot do it. From 1, 0, 1, 1, make 0, 1, 0, 0. What should happen here is, I guess I should hit this first, then it's 1, 1, 0, 1, then this 1, 1, 1, 0. That's impossible, isn't it? Why not affiliate? Mainly because I double stream to YouTube, and that you cannot be affiliate and double stream to YouTube. Make tutorial how to practice. I did that. It's called how to become red in Codeverses. But you should use this page. I'm again pasting in the chat. This is how to practice for contests. Is my logic flawed? This is just impossible then, right? Because if I do this 1, 1, 0, 1, I can hit u, then 0, 0, 0, 1, 0, 1, 1. Wait, something is wrong about parity in my mind. Let's draw this. Can I do if I start with that, I lose immediately. I need to start with u. That will flip the previous one and u. And now there are two paths. Either hit the last one or hit this one. Okay. Then this must follow with that. Not with that. Oh yeah. This is perfectly possible. So we just cannot do the last one at the very beginning. What's the issue here? The issue is that in this situation, if I hit U, then this is bad. What about always saying that let's first fix all of this and then hit U? This is more like looking at the rightmost one. Will I need dp? What is this spam on YouTube? Use English. Again, how about going from left to right? If 1 comes in second string, then I have to make all ones before it in the first string to be 0. If it is odd, then we have to take one more from the right. You need to learn Indian. I don't think that's the easiest solution here. Going from left to right. If a 1 comes in second string, then I have to make all 1 before in the first string to be 0. Why? No, I don't speak Spanish. If this happens when I go from left to right, let's say this, then I have to make all 1 before in the first string to be 0. What, that? I have no idea what you're talking about. What about thinking that we can remove 2 consecutive ones, or we can shift 1 to the left? Because if there is 0, 1, then I can change it to 1, 0. Will that help? The number of ones can only decrease. When there is a 1 here, will the leftmost one become u? Then there's, let's say, 1 here. Maybe for every 1 in the second string, I'm going to look for the next one in the first string to say that's the number of operations, and as an extra, I need to get rid of the remaining ones. How to do it? By, let's say there's a 1 here and 1 here. I need to bring one of them to the other and then cancel them. Would it help if instead I would move this one to the left and this one here to become u? I don't think that makes any difference. It's the same. Okay, I like this new solution. It helps to understand that we move 1 to the left or we cancel 2 consecutive ones. It also explains why the parity of ones doesn't, why parity of ones matters. And also we cannot get to ones if we have just 1 at the beginning. Cool, that's my new solution. So this basically gets erased, but for every 1 in the second string, find next or this next occurrence in A. I will use 2 pointers for that, I think. right? But I don't care about those that were already taken. So there will be some second pointer. Now if this already reached the end, then it's impossible. Then operations are increased by the difference, the number of steps, so like next minus I. From this position in the first string, I need to bring something to the second string and then continue from the next one. I think that that's enough. No, it isn't enough. It isn't enough if the first string is like that and the second string is like this. Then answer is of order O n square, because you need to bring this one here, bring the second one on the second position, and so on. That's the case where the answer is quadratic. But there are those unmatched ones. So let's say that, oh, I know what I can do here. And next is false, then even this is not necessary. Just unmark this. And now go for everything. If you are still there, then pairs pushback I need to match them with each other. Let's say if pairs, actually it's not pairs yet, it's more like unmatched. If unmatched is 2, 3, 8 and 12, those are positions of ones in the first string that are still there, and I will say that 3 needs to go to 2 and gets cancelled with each other, 12 needs to go to 8 and gets cancelled. If the number of those is odd, then impossible. Else, a pair up unmatched of I plus 1 with unmatched of I. No. Why? This should work. Why it doesn't work? Okay, we get here and match this 3 and 4. What happened? No, I wanted to say that I'm running wrong file, but that's not true. This... What? Unused one. Chat, are you talking to me, or like is there some issue with my code, or are you talking with yourself? If there's something wrong about my code, at me, like write at Ericto. This is good, right? Like if size modulo 2 is 1. Why was -1 printed? We got here apparently. Oh, I see. Operations was -1, right? That's so unusual. I got -1 in the output, but it isn't because of this line. It's because of some other bug that made operations negative. So unlucky. Yeah, then I guess here it will be next minus I. Oh yeah, next cannot be smaller than I. Okay, and I also want to check that if it's something like this, then the answer is of quadratic size. Indeed, 25. In general, it will exceed long. Nice. Does anyone have a good website for understanding for loops? You need some C++ course. Also, you won't really gain a lot from this stream if you're on the level of for loops now. I'm solving here very difficult problems. Was problem A easy? Yes, it was. 2 minutes of thinking. Do you use same keyboard as Gennady? You're asking a bad question. How does it matter, and why would you think that it's the case? No, keyboards are not important. And I heavily doubt that I use the same keyboard. I actually doubt that also any of you in the chat have the same keyboard, because my keyboard is very old. All right, new problem, robots. I will start in like 2 minutes. Need to do something first. If you go to description, or if you go to my frequently asked questions, you will get all my hardware and software, including keyboard model. I think it's Logitech Ultra X Premium. Some very stupid name. Like Nerwala's keyboard sounds so good. Maybe, but I use a keyboard that is comfortable for me mainly, not because it makes sounds. Background noise, it's just temporary. Water boiling. It will stop. Alrighty, robots. The robots on number line from 0 to almost infinity. We have many balls. We get some pairs saying, for example, there are 5 balls with number 10. Now sequence of operations. Choose 0 or more balls and replace integers written on balls with positive integers of his choice. Eat the balls one by one in any order of his choice. Without destroying robot 0. This just means that we cannot attack robot 0. We cannot enter its place. If we eat ball 5, then it will go to position 4. Doesn't this just mean we cannot ever eat a ball with number 1? The question is how many numbers at least we need to replace. Eknerwala's keyboard make your ears bleed? I thought that it's actually nice sounds. Does it make sense to do Atcoder Grand Contest if we introduced to competitive programming 3 months before? No. You can look at first problem and try to solve it, but likely you can't. So even if you tried, you will be stuck in the first problem, so that should tell you if you should try. Got an offer from Microsoft? Nice, congrats, Giant. And hi, Jaypool. Oh, it's not that robot from position V. If robot V exists, if we eat 5 and then we eat 4, no, if we eat 5 twice, it will move twice. But if we first eat 5, it destroys 4, so then we can eat a lot of 4s and nothing happens. I think I understand the statement, but let's make some drawings. Let's say there are robots from 0 to 5. If I have a ball with number 4 written on it, and I use it now, then 4 will move by 1 to the left, and it will destroy this robot. Let's say that I have another ball with number 4. It will move this 4 even more to the left, and it will destroy a 2. The cool thing about this is that now balls with numbers 2 and 3 don't do anything. Now, I lose. If this happens now, I lose, because 4 will move here, destroying 1, and there, destroying 0, and that's forbidden. I lose if I destroy 0. Imagine that there is some border here. If I try to hit it, I lose immediately. If I have 4 4s like this, then I will lose unless earlier somebody from the right hit me. So 4 needs to be destroyed by your neighbor from the right. If I write, maybe it's good to write down range for every value. The range is how many occurrences of that we have. The fact that it goes further than 0 doesn't matter, in my opinion. But if 5 can get up to here, if 3 can get up to here, and I don't know, maybe also 1 can get here, and then what happens? 5 would need to destroy 4, because 5 is the only one able to destroy 4. But then 4 isn't able to destroy 1, so we lose. but if this one isn't here, if those are the ranges, then we can win by saying that 5 goes before 4. There is actually, this is a long sequence of robots. Long sequence of robots. And for some of them, let's mark them as dangerous, because they can reach 0. If they are dangerous, there must be somebody from the right destroying you. In particular, there must be somebody destroying this guy. They can destroy each other too. If you can reach here, then you will destroy them, but you need to be destroyed later anyway. So it means that on the right there must be somebody reaching this position anyway. So let's say that reds cannot destroy each other. Destroy means to kill it before it gets to 0. So on the right there must be somebody covering some reds, then there must be something covering some more reds, maybe like that, and like this. The blue intervals can intersect. But blue means that it cannot get to the very end. And then I will use them in order 1, 2, and 3. How to get motivated to code every day. I won't tell you what motivates you. I like coding, so that's my motivation. I saw you on YouTube. All right. Can we use Python? You can, but C++ is better for competitive programming. Replace integers written on balls with positive integers of his choice. Hit the balls in any order. In particular, we can replace with some huge number, and this will basically do nothing. So we have the current situation, and then in one move I can change some number from the input. Let's say I want to change this to, and I can change it to other existing value like 4, or to some arbitrary value like billion. So it would kind of just erase this element. For every red then, let's say that I cannot cover something red. For every red, I can remove some occurrences of you. Let's say that this red is 8. I think it's 9. Right. There are some balls with value 8. I can remove enough red balls enough balls with value 8 to say that this doesn't get to the end, only gets here, and then it stops being red. For 3 also this becomes blue, so erases all the balls on the left, red balls on the left. So if it's enough to do it for 1 red. Among reds, only one of them I will do this, I will change you to blue. For everything else, instead I need to cover you with blue. And that sounds like DP. I think that every red will just cost 1 more blue. I think that I need, if this is not covered, I need just +1 operation for you. If this is not covered, I need +1 operation for you. Not covered means that no blue reaches you, but then it reaches at least this position, so it's just by +1 going from the right. So this will be the number of non-covered reds on the right plus how many times I need to use you. That's the solution. I first need to understand where are reds, and then which of them are already done because they are covered by blue. And let's say if there are any, then I will completely forget about them. If this red is covered by some blue, yep, forget about it. That will be the first step. And then for every red, I need to know how many times it occurs and what is its position. So how many times I need to erase it. And it will be, the possible answer is this difference plus the number of reds on the right. Done. Okay. Before I code, once again, the problem statement and summary of solution. There are some numbers in the input. Let's say there is like 3, 3, 3, 3, 3. This means that, and there is also some sequence, infinite sequence of numbers. 5 threes, it means that I take a number 3 and 5 times I move it by 1 to the left. When I move it to the left, it destroys the other numbers here. If 0 gets destroyed, I lose. So no, 3 cannot get here. If only this was the input, it would mean that it would be fine if I remove 3 threes. By, for example, changing them to 100 and this to 200 and so on. Because I don't mind the fact. I'm allowed to do that. And so there are 3 operations here. But also, if I replace one of 3's with a 4, I can say that first I move 4 because I choose the order of those. And 4 will move by 1 to the left, 3 gets destroyed, and then those 3's are ignored. This 4, because I use it, I called it blue. 3 I called red because it's dangerous, I need to kill it. And now my solution is, on this long sequence of values, possible values, for each of them count how many times it occurs in the input. If enough times that it can get to 0, then mark it red, meaning dangerous. Then the next step is, if something there is also, let's say, 5 in the input, so something blue, this means this 5 can get here, it will kill 4. Then actually 4 is not red. Red means that it occurs enough times that it gets to 0. So definition of red is the number of times, the frequency of this value is at least equal to the value. And second condition is not covered by blue. By blue. Then it's red. And what I need to do is I need to say that sums, let's say 7s will get erased. So then 7 will change thanks to that to a blue value, a helpful value. So it will also deal with reds on the left. Plus I figured out how I can in one operation fix every other red on the left, on the right. I will not repeat that part. Okay, that's my solution. And I'm solving this problem, C robots. Link to the whole contest in description of YouTube video. Can we change integer of all balls? Yes, you can change all values. You need to change minimal number of them. And you need to use only integers. This and like that. And then increasing values. Wait, what? Alright, because the input says, for example, that there are 5 balls of value 7. There will be I balls with this value. Fine. Fine. So the first row is increasing. This is increasing, so values, and this is not increasing, it's frequency. For every I, if B of I is greater or equal A of I, then this, those are pairs value comma frequency. Else this is blue. Oh, yeah, not. I didn't initialize A and B. This is red, and blue can pop some reds. When I see a blue one, it has some reach defined by frequency. So while not reds empty, and some condition about reds dot back dot value. This is position of the last red. Let's think. If the position of the last red is I is equal 5, and now my current position I is 7, then I need at least frequency 2, right? Yeah. So if the current frequency greater or equal to the difference I minus that I AFI. AFI is the current position, this is previous position, this is how many times I move to the left. Okay, well, this reds dot pop back because covered by blue. For everything in reds, possible answer is however many times I need to decrease U by 1. That's the difference reds of I dot second minus reds of I dot first. Plus 1, because if it's 5, 5, then I still need to decrease once. That plus how the number of remaining things on the right. On the right, that should be the correct formula. This is 1. 1 indeed. I don't like weak samples here. It's a tricky problem. I would prefer if they just, use like 5 samples. Maybe it would reveal the strategy too much. I'm not sure about it. I would use more sample tests. Oh. Pink comment is nice. Maybe. By default it's gray. I changed it to pink to make it more visible. What now? I pass sample tests. Some max tests too. Can the answer be long? I don't think so. I can deal with every red by +1, right? Because there is some. I go from the right. For every red, I just expand the last blue by +1. If there is sequence of reds, the first one will get +1 by blue, and then +1 by blue, +1 by blue. The code is right now very short. Atcoder problems are often beautiful like that, where you think for half an hour and then the code is just 20 lines. maybe 30 lines, but still it's very, very simple. Let's read the code and find maybe some off by one mistake. I think this will be easier to read. Frequency of I, it's at least the difference of positions. Like if 7 and 5, then I want at least 2. That's right. What about this? Maybe here I pop something that I should actually use in a solution. Share your CPP template file for taking inputs. I don't have template for taking inputs. You take inputs with scanf. I prefer computer science. I don't know anything about cybersecurity. Yes, Atcoder problems are kind of mathy. Not that heavy math. Let's try to create this. I'm worried about the popback thing. Can it happen that red. Why in code forces my stream isn't visible? Oh. That's so bad. I think the issue is that I started on Twitch maybe 1 minute too late. You know, Codforces has this feature of showing coming streams on the right. Anyway, let's imagine a case where something is red but barely red. With one operation I can change this to blue, and there is some blue here and it kills it, sure, but there are some more reds and they are big. Yeah, then in this case I will get better answer by using this red to change it to blue. Oh, actually this is exactly the solution. Let's say that number 1 occurs 10 times. Number 4 occurs 10 times. Number 1, 2, 3, 4, 5, 6, 7. 7 occurs exactly 7 times. And then number 8 occurs twice, or just once. It's possible with one operation to fix that and everything is good. But instead my program will say 2. Let's see. Great. It's great to understand why your program is failing. There will be vector for all reds. And those that are left in here, they are not removed by blue. They are indeed not removed. like that. Now we iterate over all size. This stays as red.size because it's enough to handle them. All.size. On the right should be not removed size, but first not removed, erase this so that this is handled. Then not removed now contains only remaining things on the right. Okay, no, all. Let's try again. I'm hopeful about this. This was a legit mistake. The mistake was a red that is covered by blue, so it isn't an issue anymore, still can be useful in decreasing the answer. Well, that wasn't a mistake, or at least it wasn't the only mistake. 19 wrong answers. Actually, I think it's the same. I fixed 2 wrong answers. We're moving forward. Best of luck for Hacker Cup finals. Thank you. We had to watch from the beginning to see the problem. You don't. You can at any moment, in the description there is link to the contest, but also you can just Google the title or something, and you can read the statement yourself if you're joining in the middle. Your stream is one best of its kind, but this Atcoder hard stream, it will not attract many viewers, you're right, because it's hard. That's it. Your CPP file where main and task are empty, this kind of file, you can get my templates in my GitHub repository. Just see the description of the video or stream before you ask a question. What else? When I fix a red, it will kill everything on the left. If something is blue, then what? It covers some reds. If red first moves on the left, and then somebody from the right kills it, it would mean that the thing on the right could kill itself. All the things on their own, so red is not needed. I don't see an issue. Is this coming at YouTube? You can watch on YouTube. Also later it will be saved on YouTube. When Facebook Hacker Cup finals? On Saturday. I don't know if anything there will be streamed, if you can follow the results or anything like that. You can on Facebook follow Facebook Hacker Cup page, and then they will for sure announce it. Alright, let's treat standings, not standings. Okay, standings are fine. See robots. Copy. I'm not looking. Okay. Now let's write a generator for small random tests. What is the input? That is the input, fine. N is from 1 to 5 should be enough. Will this compile? I don't know. I'm creating a set with n values. The sequence A must be increasing. That doesn't work. If you want to generate increasing values without repetitions, then set is most convenient. Then n arbitrary values. I have a video on generating tests or like stress testing. If you search for how to stress test or something like that, you will see the whole lecture about it. Stress test C against his. Well, failed on 27th test, and it's a very small test. I say 3, he says 2. On 1 there are 6, on 3 there are 4, on 5 there are 9. This can be killed with one operation. This can be. How to do this with 2? Are we gonna play more coding game? No, coding game finished. It was a 2-week contest. You can absolve, but it's not that fun. What are your PC specs? There are some comments for that, but generally check frequently asked questions before asking. Okay, somebody tell me how to do this in 2 moves in this problem, because I have no idea. I guess that this 3-4 is something useful. It works now. This apparently is decreased to 2. Oh, I see. Those are not separate operations. Operations in this problem aren't to remove a number and to insert a number. It's to change something. So when I decrease this to 2, this gets used to cover other reds. Okay, my formula is wrong. Reds.size, sure. On the right is this. And erased is that. And now, if I need to erase 3 times and cover 4 guys, that will be 4 operations in total. Because erasing 3 and making 3 new, each of them is just one operation. not this. I think I would get this if I just, you know, reread the statement. That was problem C, robots. From Atcoder Grand Contest 49. So we are here out of 6 problems of very quickly increasing difficulty. And it's accepted. That's great. Right. This is done. Now we will move to D, convex sequence. The stream is already 1 hour and 30 minutes. So I will solve D, and that will be the end for today. There are also 2 very hard problems, but I'm not able to do all 6 in one sitting. I could, but it wouldn't be pleasant. It would last like 5-6 hours. Let's try the convex sequence. At least the statement is simple. I mean, it's short. Find the number of sequences with given length and sum of values such that this is true. This is a condition about, you know, if you divide both sides by 2, you will get AI is smaller or equal the average of 2 neighbors. In other words, if you draw this sequence, if you draw where it should be for 1, 2, so let's say A2 value is 5, then there is some A1 value, A3, and so on. It must be convex. It must look like this. This, or the other way around, wait. AI smaller equal, oh, sorry. So not like this. Instead, it should be like that. Possibly with ties. This exactly means that every value is below the average of the 2 neighbors. And I'm guessing already that complexity will be something like that. And I'm guessing that it will be about this. If something is increasing, then it will keep being increasing. And if you want the sum m, then you can have at most that many different values. So it can be constant for some part, but once it's increasing, the length of this part is only square root of m. Hence, I'm guessing that that will be the complexity. And also nm are small enough that square root will pass. What was your ranking in coding game? Around top 500. I got to Gold League. Erich Life could be a cool name. When will you rename it? Oh yeah, I forgot. I will change Erich 2 to Erich Life because that describes my channel more. I will do it. So let's focus on this increasing part, indeed. This one. We can have something like dp of length and the sum, but that cannot be enough. The length we know is up to square root of m. Maybe length can be encoded in sum? No, that's a stupid idea. I know. First, let's just assume that n is up to square root of m. Can I solve the problem then? Can I solve a problem for small n? The problem is D. In this contest, in Atcoder Grand Contest 49. Yeah, I live with my girlfriend. What DP can I do? It's quite obvious that we should think about DP. DP can count sequences. Well, if I know the last two values, it will give me some requirement about the next value. But I cannot have dp of length, sum of everything, and also last two values, a and b. That's too many dimensions. A and b are both up to m. Sum of all is also up to m. If I instead investigate sequence of changes, this change is, let's say, +2. Every next change from this value to this one must be not smaller. And if I put +2 here, it means that everything after that gets +2. That seems to be a better idea. We have a sequence of differences between two consecutive values. If I put here +2, or just let's say here +2, it will mean that this number, this number, this number, and this number, they all get increased by +2. So there is a multiplier here, times 4. This is one condition, and the other one is that values are increasing. I can go, let's say, from the right, and it will be dp of position or length, the last value, and the sum of everything. The number of values here is m, but here it's only m over 2, m over 3, m over 4, and so on. And the sum of that, so the number of pairs I and last value, is only n log n. Or just m log m. I don't care. By this I mean the bigger value. But this s is also m, so the number of states here is not smaller than m squared. Anytime in future will you introduce her in stream? Not likely. This is programming stream, not my private life. Oh, actually, I have the Facebook Hacker Cup hoodie right now. They sent a new one. But I actually wonder if it's confidential how the new hoodie looks like. Actually, it's not a hoodie. It doesn't have this thing, a hood. So the new one for the Facebook Hacker Cup finals that will be on Saturday, it's not a hoodie. But we are obligated to wear it during the finals day, even though it's online. We're getting somewhere. If I remove one more dimension, I bet that transitions will be easy enough. I practiced some inclusion-exclusion like a month ago, and now often I think about it, and it only wastes my time so far. Here also maybe I should look at neighbors, and I should think, okay, what about cases where this value is bigger than this value? Does that help? Because if I know if I know the number of sequences such that I don't care about this value about neighbors, like the value being greater than next value, but I have some pairs of neighbors and I know something about them, then I can use inclusion-exclusion. But I don't think we can do that here. Control-C. Could you repeat why last value is log m? I mean, not last value is log m, but the number of pairs, items, and last value. Because the number of possible values here is m, then it's m over 2, m over 3, and so on, like here. Because this value gets multiplied by 4, it can be at most m over 4. And if you sum up m plus m over 2, m over 3, m over 4, and so on, m over 5, blah, 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 that's a well-known sum, like in prime sieve. For same reason, prime sieve that isn't quadratic, it's m log m. The number of pairs I and last value is limited by m times log of m. Atcoder often has a very hard dynamic programming problem, and it would still work very well with subtasks. I started with some crazy solution, n to 4th or 5th power. Now I have m squared times log, and I would need to think about transitions. But how to decrease the number of states? Can I get rid of last value? Last value guarantees that the function is convex, while s is needed because I care about the sum of everything. So far, I don't see it. What do we do? This is problem D. That D is very ugly. Any ideas, chat? I need to know the index to know the multiplier. I need to know last value to guarantee the convexity, the convexness. Maybe convexity is a word. And I need to know this because in total I want m, and the sum of everything being m. My only idea is to remove this by using inclusion-exclusion principle. But then I would need to say what's the number of ways to do this, such that, let's say, this pair is bad, and this one, and such iteration over all possible triples of adjacent pairs to say that, oh, actually, this is a bad pair, so, well, this should normally increase. Let's consider cases where this is +4 and this is +3. In particular, we will consider a case where everything is like that, and that's equally hard as the initial problem. Or maybe not. Actually, maybe not, because values on the left are small. I'm not getting good at CP, even after solving more problems. Can you please help me? Practice, I mean, in description you will find GitHub repository and how to practice page. So that's my advice. I don't know what else you expect from me. Should I say that you should give up or that you should not give up and move forward? I have no idea. Using two pointers which satisfy the condition 2, and from that point to another look for some of those then. I mean, there is a long sequence. It's not that we care about single interval to use two pointers. And let's also remember that I is only up to square root of m, because then multipliers will get too big, or something like that. What about this s? The last value is kind of arbitrary. Can go up to the infinity, like up to s. Is there any pattern here? We can go up to m over 2. Oh, wait. Not really. This can go up to m, but we have a condition. This is smaller than that, right? So this is actually limited by m divided by 3. Because not only you get multiplier times 2, but you get it plus 1. Huh. The differences must be increasing, right? Let's say plus 3, plus 3, plus 5. then what if we investigate differences of those indifferences? Between those two it's +1, between those two it's +2, between those two it's 0, and each of them affects the suffix of the sequence, so it's like second derivative. Making +1 here increases u by +1, u by +2, yeah, u by +1, u by +2, u by +3. So multipliers there are new multipliers, and this time there are times 6, times 3, times 1, times 10, 15, and so on. It's how second derivative of a function affects the sum of values till the end. And now I don't have any condition about that. This just should be non-negative. And now it is dp of I and sum. And I only need to consider up to square root of n or m, because more will not fit. The multipliers will grow too big. That's nice. Seriously, 2 hours for a single problem? No. Why are you asking? I'm indeed streaming for 2 hours, but it's the 4th problem. That being said, for a hard problem, yes, you need 2 hours. I need 2 hours. The best people in the world to do, because problem is hard, just like in math. Some problems stay unsolved for years. Then it's not strange that something is not solved for 2 hours. I go from the right side of the sequence. I do this, and then I know something about possibilities for the increasing part, kind of. Let's remember that I have this long sequence of length n, and I can decide that every value will be at least something. I can decide about minimum of this sequence. Let's say that everything by default is 2. Of course, the number of possibilities is limited by m divided by n, because already this is twice n. And now I can choose to increase some prefix. So instead of 2 to 2, it will go up here. And instead of 2 to 2, it will go up in some suffix. Maybe actually instead of this, it will be 3, 5, 10, and 20, or something like that. And here, same here. It will be 2, 4, 10, and 100. I need, yeah, that's it. Iterate over this. In my sequence here, this sequence with multipliers, the leftmost value needs to be positive. It will mean that really this takes off. And I will iterate over this spot where from this it grows to the right, and here it's constant. Maybe it's just of length 1. But there is this middle part from here to here. It's constant, equal to 2. Then from some preprocessed array, I will read the number of ways to achieve something there. And when I have this, the dp of, I have dp of 4, the length of this is 4, And let's say there I increased everything by 30. This is the number of ways to choose numbers here so that the sum of them would be 30, and there are 4 of them if we don't count the 2, the minimum that is everywhere. This assumes that everything is 0 by default. I need to multiply it by dp of here 3, but actually anything smaller or equal than n minus 4, or smaller than n minus 4. The length of this is n minus 4, and the length of this increasing suffix can be up to it. And here is m minus 30. This is the number of ways, assuming that everything is 0. Exactly. But also maybe everything is 2. There are that many ways. I can iterate over the minimum. Can I do it? If n is small, then it hurts. In particular, if n is square root of m, then this is another square root. And I cannot have square root times m times square root. No, that's bad. And this needs to be a sum, m minus 30, but also m minus 30 minus n, m minus 30 minus twice n, and so on. Kind of a prefix sum, but with some period. This would represent that everything by default is 1. And if I have those prefix sums, then it's enough to iterate over I, over sum on the left, and just read this value from a single prefix sum preprocessed two-dimensional array. Oof, that's a nice problem. The stream is 2 hours. Do I want to implement this today? Do you guys want to see the implementation? Or should I call it a day and just implement on my own time? How do you keep up with your motivation when you feel too low that you want to give up? I mean, if I really want to give up, I will just give up. But I can continue if I have some goal, right? Like here, I like solving problems, so that's my motivation. That's why I solve problems. If it's a contest, then my motivation is to win. If you are talking about learning something because you want to learn it, then that's your motivation. You want to learn it for some reason. Now or never. I wouldn't say now or never. I can implement it whenever. All right, let's think about details of that. I said something about multipliers. What is that exactly? Well, if there is some, let's say we're investigating suffix of length 2. Everything so far was zeros, and here I want to have increasing part. That may be like a 5 here and 40. This would mean that I got a difference of plus 5 here and plus 35 here. This means that that second derivative, it's first plus 5 and then plus 30. This means that now every next first derivative, so the difference between two consecutive elements, gets increased by 30. And this plus, how this contributes to the sum is 5 times 3 plus 30 times 1. It's 45. Yep. So we go actually from the right. We have dp of I and sum. and the multipliers are 1, 3, and in general it will be for, let's say, the first one, should I call it 0? No. 1 is 1, the multipliers are like that. And for I, then it's what? I times I plus 1 over 2. For now, I will implement most things here with brute force. Then I will try to get accepted with that. Not accepted, I will try to pass test. Then I will improve. Oh, my PC did some unnecessary work. Stress testing of the previous solution was still going on. What's the order in the input? NM. This is this pre-DP, pre-processed DP, of size square root of or something like that by m plus 1. What's the square root? It should be such a value. Let's do it like that. Oh. Should I compute it exactly? This must be true, right? I times I plus 1 divided by 2 greater, smaller, equal m. Then this is twice m. Then I will say square root of twice m. It's magic something. Plus 3, just in case. This is dp of position and some value s. If we start with dp of 0, 0 is 1. There is one way to get something of length 0 with the sum 0. Like that. And now I can iterate over the previous sum, let's say. And from dp of I minus 1s, I will move to new state. Let's iterate over what's the current multiplier with what value it's multiplied. Multiplier is items. It's 1 divided by 2. What do we do? dp of I, s plus value times multiplier. This. Later I need to add modulo here. Right now I don't care. Fine. Now preprocessing dp done. If somebody is joining now, it's convenient if I type this. This is problem D, convex sequence. Might be more like prefix and suffix. This is length of increasing prefix. There is also one sum, the other sum for suffix, and it will be something like prefix s times dp of suffix s2 times something. If remaining modulo n is 0, this means that I can distribute the minimum properly. Like if length is 5 and the remaining sum I need is 15, then the minimum will be 3 everywhere. Then just this. But I think that first of all the sum of lengths needs to be at most n, so that minimum would be somewhere. That's first condition. And the second is that I want to say that the first value in that, let's say, suffix of length 2 is actually greater than 0 already. Maybe I need to go through this again. And I need to say dp of is minus equal something. Minus equal the possibility of not taking it. Yeah. This, just let's decide about the order, because that's important. This now counted all the ways. Now I want to subtract all the ways where the previous value is 0. Then this should work. I hope. Sum of lengths doesn't exceed n. Right? First try. I mean, this will be my first try. Don't claim that I will be correct from first try. Instead of 7, we got 10. The link command works only on Twitch, but you know, you can always get description of on YouTube video to get link to the whole contest. Are there smaller samples? There aren't. I can make my own. Is this correct? If I want the sum 2, then it needs to be 1, 1, 0, 2, or 2, 0. Yeah, that's the smallest counter test. Let's save it as in, and let's debug it. The answer should be 3. It's 2, 0, 1, 1, and 0, 2. That's it. Let's first print what are values of dp. Some value is too big, so let's only investigate positive ones. With length 1, there is one way of sum 1 and sum 2. I agree with both. Fine. Now, dp is calculated correctly, at least for n equal to 2. Then I iterate over s plus s2 cannot exceed m. Still bad. Oh, this is terrible. M is the total sum minus s and s2 taken from prefix and suffix. Now it's correct. Let's try 3, 3. It should be 7. it is 7. Then let's try something bigger. 10 and 100. Don't I get overflows? Surprising. Is that the correct answer? Oh, it is correct answer. That's great. Oh. How long did it take you to become so good? 10 years. Why are you streaming on second channel? Because it's channel for streaming. Check frequently asked questions in the description. Both these questions would be there. Are there. Alright. Let's speed things up. Well, this is a bigger deal. I need, when I have some prefix, also for big N won't I have some kind of error? Oh yeah, error, because prefix can only be up to K. That should get rid of errors other than overflow. Cool. No. When I have dp of prefix and s, I want to pair this up with dp of something smaller equal than n minus 1 minus prefix. And here there is something like m minus s minus multiple of n. I need prefix sum on that. Are these two-dimensional sums? Necessarily. I mean, can be done. That's first. dp of is plus equal dp of is minus n. That's second. Now it should be this kind of prefix sum. Oh no, that's prefix dp. I don't want to modify the initial dp. I still need it. And now I will know that the dp of pref s needs to be paired up with this thing. Max suf is n minus 1 minus prefix, but it's still limited by k minus 1. Then max sum is m minus s, and that's it. The answer didn't change. Oh, something happened here and there as well. Can I do it like that? 81 in this line. out of bounds index 1. Now it will not be negative. Seems good. Great. And that's already here square root times m, because k is square root. So this is fast enough. And then I need to speed this up and then also add all the modulo operations. But that is not a big deal. And everything will be quite slow. Look how many times this is square root times m, this is square root times m. Now if each of those parts it takes half a second, then in total it will be 2 seconds. Why people don't like Java? Learning Java is a good idea or not? Sure, it's fine. For competitive programming it's bad because it's too slow. C++ is better. Maybe this is actually fast enough. I'm not sure. This is not times m. Most of multipliers are huge. But what happens for I equal to 1? Okay, for I equal to 1 this is already quadratic, right? Yeah, it is. So this wants to take the sum that over every next multiplier. It's kind of prefix sums over just the previous row. What if I say this? This already holds what I need. So this, if s greater equal multiplier, it works. That was easier than I expected. Yeah, we need add self, sub self, multiply. Functions to compute things modulo billion7. I will try to make them fast. For that you should avoid using modulo operator when possible. Alright. I understand that this part is boring. Actually, maybe what I should have is a struct for this. A lot of people, they just use a struct to compute stuff modulo. And it saves time. I wouldn't need to do what I'm doing now. And also I can make a bug while doing it. But I prefer to do this because I understand better what is happening and I can optimize when needed. Like here, the way I'm implementing this line is faster than whatever I would do in a struct. What? Add self. Okay, two things. One is this last big sample. Should be 6, 9, blah, 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 3, 4. Alright, and the second thing is the speed. Gini, let's say into. One is this, time the on into. 300 milliseconds and not more than that. Okay, this is fast enough. I'm happy that again code turned out so simple. Now this part doesn't matter anymore. I can leave it as well. But if you remove comments, then what will you have here? 40 lines of real code? How do I make sure that my message gets read by Aristo? Well, in YouTube and Twitch, you basically add somebody. 600 milliseconds out of 2 seconds, so good enough. Let's take a look at editorial for two last problems. Actually, C doesn't, I don't care about C. Let M be the index I with smallest AI. Assume M is fixed. Choose a constant C initialized like that. Choose this, add something to prefix and to suffix. You have weights n1, 3, 6. How many ways there are to combine them so that the sum will be m? Oh, nice. So they treat n as one more weight. Nice. I can then simplify my approach. Can I? I have this condition about prefix and suffix. It isn't that simple. I know. I can start by saying that not only this is one, but this. The P of 0s is 1. This way I say that it's allowed to have all zeros, all ones, all twos, and so on. Now I will not need something. I think that I don't need this. My answer is messed up by 1. I have by 1 too much. Why? Why? Oh, because I consider prefix and suffix of 0? Is that it? I wonder if this is correct. But this is what happens for non-divisors. Let's get back. It was this. Oh, okay. That sometimes it's messed up by not 1. Why this is bad? I already got accepted. It's just that the editorial let me understood something better. And I want to use it. For multiples of n, I say that there is one way to get it already, with zeros or with ones, with twos. I get it. Here sometimes I overwrite. Oh, but that would only increase the answer, wouldn't it? And still, this should be now add self. No, that's completely wrong. I understand. That's wrong because I do it for prefix and suffix, right? So twice I unnecessarily add n. It isn't that easy. dp isn't for the whole sequence, it's separately for prefix and suffix, and this way I do it twice. That's bad. I could run dp once, and then in the other dp, so pretending that you are suffix, I could do it. But then this simulates exactly what happened here. Never mind then. This code can be shorter. Fine. Another great problem by Atcoder. Today I did ABCD. Let's see my Atcoder checklist. My long-time goal is to fill it with green. But there is a lot to go. I wanted this year to be done with those rounds, and no, I won't succeed here. Well, okay, this line is done because it's my contest. I just need to copy-paste problems. But still, just solving this EF, DEF, F, in total that's like 15 hours. Maybe 10, if I look at editorial quickly. But today I solved ABCD without looking at editorial. That took me less than 2 hours and a half. Would that be enough to score well? Let's say that without explanation I would do it, without explaining things out loud, I would do it in 2 hours with maybe, how many wrong submissions did I get? 2. Oh, also I cheated with Omnix code. Oh. If we don't count that, I would get 40th place. Assuming I would do it in 2 hours. It's hard to say. If I hurry it, maybe hour and 20 minutes, it's already top 20. But the contest was more than 3 hours, so maybe I would solve E. We'll see that another day. Cool stuff. Thank you everybody for watching. In YouTube description, but also in Twitch chat, you can grab various links like Discord. Oh, it's not a good link. Not a good command. Discord and schedule. So join my Discord server to have some say about my content, stream and so on, or just hang out with me. You can also write me a private message, but I only answer to those when I have time. And check out the schedule of my streams. In particular, in 2 days there will be coding interview stream, but on Saturday there isn't the standard Code Forces stream because there is Facebook Hacker Cup. Maybe I will stream something related to Facebook Hacker Cup. Maybe I will cover a global round on Sunday, or on Friday there is Division 2. I don't know yet. But I see you in 2 days, on Thursday. Let's try to rate somebody if somebody is doing competitive programming. But I don't think that's the case. Then that's it. Yep, no other streams. Fine. See you. Thanks for watching.